Hello friends, my topic is the difference between serial schedule and serializable schedule. First let me see what is the schedule. The schedule is the sequence of the read-write operation of several transactions as they are executed in a database. Uh, they are divided into two types, scheduler, which are they are serial schedule and serializable schedule. First of all, let me see what is serial schedule. In serial schedule, all statements are in the same transaction are executed cons- consecutively. So this ensures that the same transaction is they ensure that the entire transaction is completed before any other transaction begins. And there is no interleaving or mixing of statements from different transactions. Each transaction is isolated and its statements are executed as a single and uninterrupted unit. This isolation helps maintain the consistency of the data state. And the serial schedule are conceptually simple and easy to understand. The execution order is linear, making it very straightforward. In addition, um, the transactions are executed one at a time without interleaving. There is a lack of concurrency in the serial schedule. This absence of concurrency execution simplifies the control flow of the system. It reduces the complexity of the managing simultaneous transaction and make it easier to reason about the correctness of the database. Okay, there are 4 points related to the serial schedule. Let me see one by one. Transaction executed fully. In a serial schedule, a transaction is executed in its entirety before the next transaction begins. This means that all the elements within the transaction are processed and completed as a single invisible unit. Then one at a time. Transactions are proceeded one at a time in a serial schedule. The system focused on the complete execution of one transaction before moving to the next transaction. The third point is no interleaving. There is no interleaving or mixing of operations from different transactions. Each transaction is allowed to finish without any interpretations from other transactions. Then the different orders of execution yield different final values, which means that while the transaction execute one at a time, the order in which transactions are executed can impact the final state of the database. Okay, let's see. Here is an example of a serial schedule. Um, in this example, there are two transactions, T1 and T2, and in first T1 table transaction, there are read A and write A and read B, write B. These are the operations in the first transaction. First of all, this all transaction is happening one after another. The one transaction is happening after completing the above transactions. After completing the whole transaction T1, it move on to the transaction T2 and like represented in this table. So this is an example of a serial schedule. This is also another example of the serial schedule. In this table, the transaction T2 is executed first, then it commit, then after completing the whole transaction, it transfer the T2 operation, T1 operation is performed. Okay, now let me see the second schedule named serializable schedule. The serializability of a schedule is used to find non-serial schedules that allow the transaction to execute concurrently without interfacing with any one other transaction. This means that even through transaction may execute concurrently and their operations are interleaved. The final outcome which be uh, equivalent to some serial execution ensures consistency and concurrence of the database. And these are the five major points related to serializable schedule. The first point is it is interleaved. In a serializable schedule, transaction can mix their action, ensuring the database stays correct. And also, it is equivalent to some serial schedule. Serializable schedule guarantee the end result matches what would happen if transaction occurred one after another. This keeps the database in, intact, typical mixing up operation, and it is equivalent and independent of initial values. Different schedule should give the same result, no matter the starting value, whether transactions are mixed or follow a straight order. The final outcome remains constant, and they are independent of return values. The equivalent does not relay or specific values returned by transactions. The final database system, the equivalence, does not hang on the actual data values and during the execution, and which is depends only on the order of operation. These are the major 5 points of serializable schedule, and there are mainly two types of serializable schedule. They are view serializable and conflict serializable. Let me see what are they. Okay, the view series serializable check if the schedule is equivalent to the serial schedule in terms of their observable results. If a schedule is view serializable, if its outcome matches those of some serial schedule. Okay, let's see. Here is an example of two transactions, um, transaction 1 and transaction 2. In the first figure, the transactions are interleaved or unordered. Then let's swap the read-write operation in the middle of the two transactions to create a view equivalent schedule. It's shown in the second figure. The read-write operations are scheduled in a ordered manner, so it's become a view equivalent schedule. The second serializability is conflict serializability. Conflict serializability checks if a non-serial schedule is conflict schedule or conflict serializable. It will transform the non-serial schedule into a serial schedule by swapping the non-conflict operations. For example, if two transactions are executing, conflict serializability evaluates whether their interactions maintain consistency in a way similar to the serial schedule or not. Here is an shows an example of no conflict serializability. Um, in this first transaction, uh, it's a non-serial schedule. Since it is converted to S2 by swapping the non-conflict operation. S1 is a conflict serializable schedule. It will not violate the consistency of the database it execute. Okay, thank you.